Okay, assalamu alaikum. Welcome again, my dear students. Inshallah, today we'll talk about our topic, chemical energetics. Okay, in fact, this topic from one of the important topics at our curriculum or our syllabus because it deals with endothermic and exothermic reaction and the temperature of the chemical reaction or the energy of the chemical reaction. So, any exam should or must have one or more questions about this session. يعني أي exam لازم يكون في question about this session. Okay, so let's start. Our first question: what do the terms exothermic and endothermic means? يعني okay, term exothermic in one word means give energy, reaction at which give energy. Okay, the term endothermic means reaction that take energy. Okay, taking energy, okay. Or another way, when you catch the tube which contain reactants of exothermic reaction, it is hot tube. Okay, and if you catch a tube which contain reactant of endothermic reaction, the tube will be cold. Okay, move to next question. What happened? Okay. Give an example of a type of reaction that is exothermic. Okay, there are many types of reaction which are exothermic. For example, reaction of sodium with water. Okay, it is exothermic reaction. Okay, but at all combustion reaction, which include, for example, the combustion reaction. Okay, reaction which give high amount of energy, such as combustion of, for example, CH4 methane, for example, plus oxygen. Okay, give CO2 plus, okay, H2O. This is an exothermic reaction. Or if you add acid or base, okay, on base, this called neutralization reaction, which also is exothermic reaction. Okay, so we have many types of exothermic reactions. Okay, let's move to the next type of reaction. Give an example of endothermic reaction. Okay, there are also many types of exothermic reaction, but the most common exothermic reaction is the thermal decomposition of calcium carbonate. During the thermal decomposition of calcium carbonate, يبقى thermal decomposition. Okay, all thermal decomposition which include calcium carbonate, magnesium carbonate, and so on. But for example, if you heated a tube containing calcium carbonate, okay, and want to break down the calcium carbonate, during the reaction, the tube which contain the reactant, which is here is calcium carbonate, will be cold, or the reaction will be cold and start to be hot at the end of the reaction, when the reaction is stopped, okay, or the decomposition reaction is stopped, which gives CaO, calcium oxide, plus CO2. As we agreed before, any reactant which contains CO3 will give CO2. Okay, next question. Okay, in terms of bond energies, what happens during chemical reaction? What happened during chemical reaction? So it deals here with the bond which formed between two elements, how bonds are formed and their relation with the valency. Okay, what happens during a chemical reaction? During the chemical reaction, bonds formed. Describe exothermic and endothermic reaction, okay, in terms of bond breaking and bond making. Okay, in fact, energy, okay, during the chemical reaction, there is an energy required to make new bonds, and there is an energy required, okay, to break bonds. So energy play an important role during the chemical reaction. Okay, energy play an important role during chemical reaction. So you can say that, okay, for extended or for grade 10, during chemical reaction, energy needed for breaking bond عشان نكسر رابط for breaking bond for breaking and also making bond for breaking and making bond and making bonds and making bonds. Okay, but what about exothermic reaction? During exothermic reaction, the energy which released, okay, or given out during making bonds is greater than the energy used to break the bonds. Okay, so that it gives energy, but during the endothermic reaction, the energy which required to break bonds is greater than the energy released when making bonds. Okay, so in another way we can say that exothermic reaction, during exothermic reaction and the endothermic reaction, okay, during exothermic reaction, the energy which needed to make bond, as he say here, okay, yes, answer it here. During exothermic reaction, the energy released from making bonds, okay, is greater than energy used to break bonds. What does it mean? So let's talk about the reaction between, for example, okay, NH, no, let's talk about combustion reactions. CH4, okay, plus oxygen will give this exothermic reaction, okay, CO2 plus H2O. Okay, during this reaction there is a breakage, there is breakdown of bonds in reactant and the formation of new bonds. Here we say this an exothermic reaction. So the energy released from making bonds between CO2, okay, and H2O is greater than the energy used to break the bonds at CH4, okay, and for in the thermic reaction such as CaCO3, calcium carbonate, the breakdown of calcium carbonate, okay, which gives CaO, calcium oxide, okay, plus carbon dioxide. Here is the contrast. During this endothermic reaction, the energy required to break the bonds between CaCO3, okay, is greater than the energy released when making bonds, okay, So during this endothermic reaction, all time you feel the tube is cold. Okay, so let's move to another question. What about the reaction profile? When he asked you about the reaction profile, okay, you have to talk about the graph which contain reactant and product. Okay, it is a relation. The reaction profile, okay, is a graph. Firstly is a graph, okay, is a graph between amount of energy, okay, of reactant and product, for reactant or product, okay, and the time taken. Yani for example, for exothermic reaction, at the beginning of the reaction, okay, or during the breakdown of bonds, okay, as we said, energy released when breakdown of these bonds, okay, are greater than energy released for making bonds greater than energy used to break bonds. So the reactant will be here at the top, okay, and products will be down, so reactant here and the product here, this and the product here, P for product. Okay, this is due to the energy released for making bonds is greater than energy, okay, the energy used for forming bonds or for formation bonds is greater than the energy used to break bonds. Okay, and this is the energy, okay, and the contrast at endothermic reaction. Okay, so when you talk about reaction profile, you have to say that a graph which illustrates the relation between reactant and the product during the, okay, exothermic reaction. If we talked about endothermic reaction, okay, it will be the contrast. Okay, here, as we said here, energy, and the other side development of reaction or time here during time. Okay, the reactant will be here and the product will be there, as we learned, because the energy which required, okay, to break bonds is greater than the energy released when making bonds, and this is the direction of a, so right here reactant and here product. Okay, so when he asked you about the profile of the chemical reaction, you will write it is a graph. Okay, illustrate the relation between the energy of formation, breaking down reactants bonds, and the formation of product bonds. Okay, so let's move to next question. Draw a reaction profile for an endothermic reaction. Okay, we draw it and said that. Okay, let's use this color for endothermic reaction here, as you know. Okay, endothermic. Okay, so reactant will be lower and product will be higher. Okay, and the direction of energy change will be in the direction of product, and you write here reactant and here product and here delta H, which refer to enthalpy change. The term enthalpy equal temperature. Okay, equal temperature equal energy, so you have to know that. Okay, let's move to the next question. Okay, and this is the curve. At endothermic reaction. As you see here are reactants, okay, as we said, and here is our products. EA is called activation energy. What's meant by activation energy? When you do a chemical reaction, okay, such as burning of methane, CH4 for example, it's burning plus oxygen. You will give it heat. Okay, using light splint, using fire, using anything. This heat is called activation energy. طاقة التنشيط, activation energy. The energy you provide the chemical reaction to start. Okay, or another way we said it, to increase collisions between particles. Okay, يعني تزيد تصادمات ما بين الرياكتنتس في البداية بس كده خلاص, لأن ممكن الcollisions between CH4 والأكسجين في البداية not enough, but during the reaction between sodium for example and H2O, you do not need to give it activation energy because the reaction here is vigorously. Okay, or the activation energy will be very small. Okay, so and this is enthalpy change delta H. Okay, always the direction of the arrow of the enthalpy change to products, in the direction of products. Okay, let's move to another question. Draw a profile for an exothermic reaction. Also, you can draw a profile for exothermic reaction using the same method. Okay, by drawing the y-axis and x-axis and write here energy. Okay, energy, you have to write here energy. We here reaction progression or time, progression of reaction. Okay, okay, progression of reaction during time. Okay, and you have to remember during the exothermic reaction, reactant will be at the top. Okay, and the product will be down. Okay, and the direction of the enthalpy change will be to the bottom. Okay, and you have to draw here. Okay, another way. Okay, here this is called right here, this is called activation energy, EA, activation energy. Okay, as we said that sometimes when you burn a paper, you have to okay, give it some heat to start the reaction or to increase collisions. Okay, so another way, this is the curve. Okay, for exothermic reaction, as we said, always reactant at the top and product at the bottom, because during the reaction reactants temperature are very high. Okay, so energy here given out by making bond. Okay, from here energy given out by making a bond, and this activation energy. Okay, as we said, that activation energy required to start the reaction, and the arrow always it's a direction to bottom. Okay, let's move to the next question. Label the following reaction profile as exothermic or endothermic. Okay, as you see, reactant here at the bottom and the product, okay, at the top. So you can say this reaction is endothermic. Why this reaction is endothermic reaction? Because during the endothermic reaction, energy which required to break the bonds is greater than the energy released when making bonds. Is a greater than energy, okay, that released when making bonds. Okay, so the energy here, as you see, activation energy here are very high during the endothermic reaction. Okay, and here product at the top, and this is the enthalpy change. Okay, but this reaction here is exothermic reaction. Why? Because during the exothermic reaction, the energy released from making bonds is greater than the energy used to breaking the bond. Okay, so it will release high amount of energy. It will release high amount of energy. Okay, always you have to remember that during the exothermic reaction, okay, such as the reaction between sodium, for example, and water, okay, the energy which released is due to the bond energy, the bond's energy, and for the reaction between sodium and H2O to give sodium hydroxide in AOH plus hydrogen. Okay, there is here inside H2O what's called bond energies, bonds A energies, and between Na and OH, okay, and between OH molecule also what's called bond energy, okay. So you have to remember that, okay, the difference here at energy is due to the difference between bond energies. Each compound, okay, has a bonds. Each compound has a bonds between its elements, okay, and this bonds has energy. Okay, so the difference between the energy released when formation bonds and the breaking bonds result the term exothermic and endothermic reaction. Okay, in case of sodium and H2O, as you see, the energy which released for making bonds here, okay, is greater than the energy used to break bonds. Okay, so there is a great amount of energy will released during the chemical reaction, but during CaCO3 decomposition to form CaO here and H2O here, the energy required to form these bonds, okay, is so small. Okay, the energy required to make these bonds, okay, the energy required to make these bonds is so small, so the energy required during the endothermic reaction, the energy required to break bonds is greater than the energy released. Okay, why? Because there is a difference between energy here during the formation of those new bonds or breaking the bonds, okay, you need high amount of energy. You need high amount of energy to break those bonds. You need high amount of energy to break those bonds, but here you need low amount of energy at exothermic to break bonds. Okay, so what I want to say here, the idea here at exothermic and the endothermic, because most of students, okay, show confusion during answering this question, is that for the reaction between NaOH, Na plus H2O, okay, to give NaOH, and the composition of CaCO3, give CaO. Okay. The energy here required to break this bond is so small. Okay. The energy here required to break bonds at CaCO3 is high. Okay. So the reaction appears as low. Okay, low temperature here will produce, because most of temperature will gain here to break the bonds. So always you have to remember that the idea here during this reaction is the reactants. Remember reactants. And two examples: sodium with water, or combustion reaction, and the calcium carbonate. And you have to remember that I need here a small amount of energy to break these bonds. Okay, this exothermic. But during endothermic I need high amount of energy to break this bond. Okay, you have to remember that, and you will remember the answer. Okay, and remember the curves directly when you understand that energy required to break the bonds during exothermic reaction is small, but temperature required to break the bonds during endothermic reaction is low. Okay, you cannot understand it, okay, unless you remember the two examples. Okay, how can the energy change of reaction be calculated from bond energies? Yes, if we have a chemical reaction, okay, as I said, we have bonds between reactant and products. There is a relation between bonds broken and bonds made. Okay, so we have that we have a chemical reaction here. Reactants gives products. Okay, so reactant here will break bonds here, break bonds. Okay, bonds. Here we will make bonds at products. Okay, make bonds. New product, make bonds. Okay, so here the energy, how to calculate the energy change بقى. احنا قاعدين نقول من الصبح, from the morning we say that we are saying that temperature release, temperature gain, energy gain. So what about this amount of energy? How it calculated? It calculated by, okay, subtraction of bond, okay, total energy of bond broken, total energy of bond broken, okay, broken, minus, okay, minus total energy of bond formed, total energy bond formed of bond formed. Okay, so we can say the relation here. Okay, yes, so the energy change, total energy of bond broken, okay, minus total energy of bond made. Okay, so if you are here make a combustion reaction between methane, for example, and oxygen, we use the methane, okay, because methane are the common gas used at home. It will give CO2 plus H2O. So we have here bonds between CH4 here, CH. Okay, so we have here how many bonds we have here? We have here 1, 2, 3, 4 bonds between carbon and hydrogen. So we have suppose that the temperature of bond here, or the energy between bond here, carbon and the hydrogen, for example, only 100 joule, 100 kilojoule, or 100 kilojoule. Okay, so to calculate the bond energies at CH4, we have to multiply 4 times 100. So we calculated CH4, and we can do that for oxygen, for carbon dioxide, for H2O, and do subtraction process. But remember that we have here negative charge. energy of bonds, we sum energy of bonds minus sum of energy of making bonds. Sum of energies of breaking bonds minus sum of energy of formation of bonds. Okay, so fill in the gap. Fuels are burned to release, okay, to release energy. Or fuels burned to release energy. Okay, which colorless gas can be used as a fuel? Okay, methane. Methane is colorless gas used as a fuel. You have to know that. Okay, or hydrogen, or all of them are right. Okay, what is a fuel cell? Okay, fuel cell is a cell used to produce energy. Okay, or a cell that contains sorry. So fuel cell is a cell that used to produce, okay, electrical or a voltage, okay, as it is supplied with oxygen and fuel. For example, hydrogen cell. Okay, so fuel cell is a hydrogen fuel cell, hydrogen fuel cell, okay, which used to produce energy. Okay, fuel cell, it is easy fuel. Okay, what is the only product of hydrogen oxygen fuel cell? The only product is water. The only, because during this hydrogen oxygen fuel cell, it is like that. We have here fuel cell like that, used to platinum electrode. Okay, used to platinum electrode. Okay, and connected to what? To electrical current. So we have here hydrogen H2 plus oxygen O2. It will give us H2O. Okay, we can balance it by using half. Okay, so the only product here is water. Okay, let's move to the next question. Let's move to the next question. Write an equation for the overall reaction take place in hydrogen oxygen fuel cell. We wrote it, reaction between hydrogen and oxygen. Okay, what are advantages of fuel cells? Okay, fuel cells, which is so now we are not using fossil fuels. As you know, fossil fuels such as methane and the other hydrocarbons fuels. Okay, we use hydrogen fuels. It is produce more energy. Okay, produce more energy, but as you know, it is very expensive. Okay, produce more energy than methane, more energy. Okay, no pollution, and the continuous process. As long as fuel, no pollution. Okay, no pollution, but no pollution and they produce energy. So what are the disadvantages of fuel cell? It is very expensive, very expensive. Fuel cells are very expensive. Okay, very expensive. Materials are used are very expensive. Hydrogen fuel cell. Okay, and also high pressure tanks, and hydrogen is expensive. Okay, and required temperature affects efficiency. Okay, it's released high amount of temperature. Give an example of a radioactive isotopes that use to give energy. Okay, the most or the common radioactive, okay, isotope which is used at nuclear, okay, reactions, nuclear reactions, is uranium. U-235 atomic mass. Uranium will be hit with a neutron to give or to split it into krypton and and another element. Okay, so this way. Thank you, my dear students. Welcome. Inshallah, we'll meet again.